Hello everyone and welcome. In this video we will be discussing some tips and strategies for dealing multiple choice questions for principles of flight subject that require physics, unit conversions and formulas rearrangement. Before we get started, we will use some rules that we must follow in every question. First of all, read the question and make sure you understand what the question is asking and look for keywords. Secondly, review the answer choices and eliminate any obviously wrong answer. We must pay attention to units and convert when necessary using conversion factors. We must learn all the formulas and to use the correct formulas and rearrange when necessary. And of course, show your work. Draw the picture of every question, which will help you keep track of your calculations and spot any errors. Because it is a huge subject, we will deal with each topic individually for a better understanding. So for the first lesson, we will learn about basics, laws and definitions. As you can see here, it has 48 questions. I think it will be okay to use around 30 and let's get started. Static pressure acts A in all directions. This is obviously the correct answers. Let's see also the rest of them. Only perpendicular to the direction of the flow, only in the direction of the total pressure, only in the direction of the flow. Of course, this is the correct answer according to our theory, but whenever you see the word only or always, it must ring a bell that this question may be wrong. So, for question 1, A, in all directions. The taper ratio is, what is the taper ratio? A good mnemonic to remember about taper ratio. It's, we're going to see now, tip to root chord. So, tip to root. And a taper wing has to be something like this. And the rectangular wing, which has taper ratio equal to 1, looks like this. Root, tip. So, taper ratio is maximum 1 or less, equal to 1 or less. Which of these statements about weight or mass is correct? First of all, again, we have to remember our formula that connects mass and weight, which is weight equals mass multiplied with g, which is acceleration due to gravity. Let's see the possible answers right now. The weight of the body can be determined by dividing its mass by the acceleration due to gravity. No. The weight of a body can be determined by dividing the acceleration due to gravity by its mass. No. The mass of a body can be determined by multiplying its weight by the acceleration due to gravity? No, and the mass of a body can be determined by dividing its weight by the acceleration due to gravity. So by rearranging this, mass equals weight divided by the acceleration due to gravity. So the correct answer is D. This is how we should work. The angle of attack of an airfoil section is the angle between the... First of all, let's see what is the angle of attack. Let's throw an airfoil over here. This is going to be a massive angle of attack. The chord line that connects the drilling edge and drilling edge. This is the chord. And this is the relative airflow. And the angle of attack is the angle between the chord line and the airflow. Let's see the possible answers. Camber line and the horizontal? No. Chord line and the bottom surface of the airfoil? No. Camber line and the downwash, and chord line and the relative undisturbed airflow. So the correct answer is D. The subsonic static pressure decreases in a flow in a tube when the diameter decreases. Is the total pressure plus the dynamic pressure increase in a flow in a tube when the diameter decreases? Is the or is the pressure in a point at which the velocity has become zero? Drawing a Venturi tube here would be very helpful. According to Bernoulli's theorem, we know, let's say that this is 0.1. Oops. 0.1, 0.2, 0.3, pressure total in point 1 equals with pressure total at point 2 and pressure total at point 3. Pressure total equals pressure static and dynamic pressure Q. In order this to remain constant, we know that inside the throat the lines converge, and when the streamlines converge we have an increase in speed. An increase in speed affects dynamic pressure, which is Q, and we have this formula right here. Q equals 1/2 rho, which is density, V squared. So in order this to remain constant, because speed goes up, dynamic pressure goes up, static pressure must go down in the throat. So static pressure decreases in a flow in a tube when the diameter decreases, as we show here, because the mass flow at point 1 must be the same at the point 2 and at point 3. And so the energies, the total pressure. So the correct answer is A. Drag is the direction of and lift perpendicular to the chord line, relative wing airflow, horizon and longitudinal axis. We will keep this diagram because we will need it in this section for more questions. Let's draw an aerofoil over here. This is the undisturbed relative airflow. And this is the center of pressure. Lift is perpendicular to the radial flow and drag has the same direction. So the correct answer is relative airflow. Assuming incompressible flow, when considering streamlines in the vicinity of an airfoil, which of the following answer is correct? Converging streamlines indicate that the speed of the flow is increasing and the static pressure is decreasing. According to our theory, this is correct. Let's see also the rest of them. Diverging streamlines indicate that the speed of the flow is decreasing and the static pressure is decreasing. No, static pressure is increasing when the lines diverge. The first section is correct, but this is totally wrong. Diverging streamlines indicate that the speed of the flow is increasing, incorrect, and the static pressure is increasing. Of course, it is the static pressure is increasing, but the speed of the airflow is decreasing. Converging streamlines indicate that the speed of the flow is decreasing, incorrect, and that the static pressure is increasing. So, obviously the correct answer is A, but let's draw the picture. Let's draw an airfoil over here. Okay, I will get used to it. So right here, pressure static goes down and Q goes up at this point right here. So the correct answer is converging strip lines indicate that the speed of the flow is increasing and the static pressure is decreasing. An airplane's angle of attack can be defined as the angle between the speed vector and longitude. Oh, this is a tricky one. An aeroplane's angle of attack, not an airfoil, an airplane's angle of attack, can be defined as the angle between its speed vector and longitudinal axis, lateral axis and the horizontal plane, speed vector and the horizontal plane, longitudinal axis and the horizontal plane. Be careful, this is a tricky one. Let's draw first of all the relative undisturbed airflow, and now we're going to draw an airplane. This is something like an airplane. This line represents the longitudinal axis of the airplane and this of the relative airflow. You can imagine the whole airplane, the fuselage, as an aerofoil, if this makes it easier for you to understand. So the angle of attack of the airplane is the angle here between the longitudinal axis and the relative airflow, which can also imagine it as the speed vector. So the correct answer is speed vector and longitudinal axis. Dividing lift by weight gives load factor, aspect ratio, lift to drag ratio, wing loading. Dividing lift by weight, according to our theory, gives us our load factor, which has the symbol N. Load factor is this one, N equals lift divided by weight. So the correct answer is A. Bernoulli's equation rho is density, pressure static is static pressure, pressure dynamic is dynamic pressure, and P dot is the total pressure. Let's write it down. Pressure total equals with pressure static and Q, which is dynamic pressure, and Q equals 1/2 rho v squares. So we're looking for something like this. Let's see the possible answers. Pressure static plus 1/2 rho indicated airspeed squared. Pressure static plus 1/2 rho true airspeed squared. Pressure dynamic and 1/2 rho indicated speed squared, and pressure total 1/2 rho true airspeed squared. C, A, D, and R obviously wrong. so we must focus here. The correct answer is the answer that contains true airspeed, indicating the speed changes. But in the equation we need the true airspeed, which is this. Bernoulli's equation can be written as this is the Bernoulli's equation. Pressure total and plus pressure static equals dynamic pressure. Incorrect. Pressure total minus Q equals with pressure static. This is the correct answer, because if we rearrange this, if we arrange answer B minus pressure static equals Q, rearranging it, we come up with this, which is the correct answer. So obviously the other two are wrong. An aerofoil is cambered when the chord line is curved, the chord line is never curved. The maximum thickness is large compared with the length of the chord, the upper surface of the aerofoil is curved, and the line which connects the centers of all inscribed cycles is curved. Don't get confused by that, because we have positive cambered aerofoils, negative cambered aerofoils, so don't get betrayed. The correct answer is D. The line which connects the centers of all inscribed cycles is curved. It would be a bit difficult to draw this. I hope, yeah, you can see it clear on the explanation what this means. And this is the camber line, the red one. So the correct answer is D. Given the wing platform represented in the diagram and the following dimension, span 12.5 meters, root chord 1.5 meter and tip 1 meter, the correct values of a wing area and taper ratio or aspect ratio are let me see right here. Okay. Let's remember the formulas, first of all, of aspect ratio. Aspect ratio equals B, which is the wingspan with the average chord. We can imagine the average chord. We have here 1 meter, 1.5 as 1.25, an easy calculation, and this is the B, the wingspan. So we can come up easily with something like 12.5 meters divided by 1.25 meters, which makes us 10 as an aspect ratio. Also, one more formula of the aspect ratio, what we must remember is aspect ratio equals with wingspan squared divided by the area. Moreover, the taper ratio equals tip to root. The tip was 1 meter, and the root was 1.5, which makes us around 0.6 around. We are looking for an aspect taper ratio of 0.6, the wing area. How can the most possible correct answer is D, but let's see how we can calculate the wing area. We can calculate the area by multiplying the wingspan with the average chord, which makes us 12.5 multiplied with 125, which is around 15.5. So here, answer A, we have an aspect ratio 10, which is correct, but the wing area is wrong. Answer B has a wing area of 15.625 meter and aspect ratio of 12.5, which is wrong. Wing area 18.75 meter square, taper ratio 1/5, taper ratio and wing area are wrong, and wing area 15.625 meter square and taper ratio 0.66 is correct. Can I have a calculator over here? Yeah. So we had 12.5 multiplied by 1.25 makes us, yeah, okay, we'll solve that. Consider an airfoil section. The relative thickness is the ratio of maximum thickness to chord. This is the formula. Maximum thickness, maximum camber, no. Average thickness to medium camber line length, no. Average thickness to chord length, no. The correct formula is maximum thickness to chord length. Okay, according to the diagram, according to the figure, we must find which angles are they. Climb angle, pitch angle, and angle of attack. The line, first of all, the line of the horizon and the longitudinal axis. So we're looking for angle Z. Is the pitch angle. So, and Z must be last. Okay. What is the climb angle? The climb angle is the angle. Excuse me. The angle between the horizon and the flight path vector, and the angle of attack, as we saw earlier of the airplane is the angle of the flight path vector, which has the direction of the relative airflow and the longitudinal axis. So x is for angle of attack of the airplane. So x angle is the angle of attack. So we are talking about C or D. Y is the climb angle and Z is the pitch angle. So the correct answer is C. Question number 16. The relative thickness of an airfoil is expressed in always is percentage of the chord. So degrees, cross section, tail angle, no. Meters, no. Camber, no. It's always percentage of the chord. A wing is often designed having a different profile, shape, or a different angle of incidence along its span, creating a washout effect. Why is that? To ensure that the wing tip stalls after the wing root, to increase the stability roll and reduce the likelihood of a wing drop. This sounds perfect. This increase in lift towards the wingtip, thereby ensuring a more even distribution of lift along the span-wise direction, increasing efficiency. This reduces the drag produced by the wing as the entire wing can operate at its optimum angle of attack along the wingspan, along the span-wise direction, and to reduce the effect of wingtip vortices and therefore ensure a more even distribution of lift along the chordwise direction. The reason we do the wash in and the wash out is to make sure that the root stalls first and the wingtip stalls last, because until the end we want to have lift. We want lift at the wingtips. We want the airflow to be, we want the ailerons that are located at the wingtip to be effective until the end. The angle between the direction of the undisturbed airflow, relative wind, and the chord line of an airfoil is. This is the angle of attack. Climb path angle, now same as the angle between the chord line and the fuselage axis. Okay. Of course, here it says the definition of the angle of attack. The units of wing loading, weight divided by area, and dynamic pressure QR. Before we see the answers and get confused, let's do it by ourselves. We count weight according to SI in newtons, the area in meters squared. So the wing loading, we have newtons per meter squared, and Q, which is dynamic pressure, we also count it in newton per meter squared. So we're looking for newton per meter squared and newton per meter squared. Newton per meter squared and newton per meter squared. Newton per meter cubed, kilograms per meter squared. No. C, no. And D, no. The correct answer obviously is A. The total pressure is, again, I know that we have already mentioned it, but practice makes perfect. Pressure total equals static pressure plus dynamic pressure. Static pressure minus dynamic pressure. No, of course, this is only dynamic pressure measured at the small hole in a surface parallel to the local stream. No, static pressure plus dynamic pressure. Answer D obviously is the correct answer. In any given airflow, rho multiplied with area multiplied with speed equals constant. What is the principle known as? Equation of continuity, Magnus effect, Bernoulli's principle, and Venturi effect. According to our theory, of course, this is the equation of continuity. Considering some subsonic incompressible airflow through a Venturi, which statement is correct? The static pressure in the throat is higher than in the undisturbed airflow, and the speed of the airflow in the throat is lower than in the undisturbed airflow. Let's draw a Venturi tube again and make sure we keep it. Oh, okay, we have it over here. So no need to draw this again. So inside the throat, because the straight lines converge, because this distance is smaller, the dynamic pressure increases due to increased speeds, streamlines converge, pressure stat goes down. So let's see again the questions. The static pressure in the throat is higher than in the undisturbed airflow. Of course, this is incorrect. And the speed of the airflow in the throat is lower than in the undisturbed airflow. Also incorrect. So both of them, from what we see here, are incorrect. Incorrect and incorrect. B. Aspect ratio of a taper wing is the ratio of, let's remember the formula of the aspect ratio. I don't want to delete this. It's okay to delete this. Aspect ratio equals B, which is wingspan divided by the average chord or aspect ratio equals wingspan squared divided by the wing gross area. So net wing area over wingspan, no, wingspan squared over gross wing area. It's obviously the correct answer. Let's see the rest of them. Wing tip chord over wing root chord. This is the taper ratio. Don't get confused. And average wing top, average wing chord over wingspan. No. The correct answer is B. You can see it over here. This is what it is talking about. Wingspan squared over gross area. Given P pressure, rho density, T equals absolute temperature, the relation between pressure, density, and absolute temperature of a given mass of air can be expressed as okay. Let's remind the formula of the ideal gas, which is something I'm pretty sure you remember from high school. P, which is pressure, V, which is volume, equals N R and temperature. V is the volume, N is the amount of substance, and R is an ideal gas constant. By doing some rearrangement, pressure equals N divided by V multiplied with R. The amount of substance per volume makes us rho. And R is a constant of the ideal gas. So write this here, pressure equals rho R tough. Let's see now the answers. Let me see again the type. Pressure. What arrangement is this? No. Pressure. I'm getting confused with a small pressure. Okay, this one is the correct by doing some rearrangements. Because if we bring this down, pressure divided by rho and tau. Okay. So if you are not sure, always take your time. This is the correct. Don't get confused. Okay, pressure with a small p, but it's okay. Lift is the component of the total aerodynamic force perpendicular to the local airflow. Local airflow. No, we are looking for something like undisturbed airflow. Vertical component of the total aerodynamic force perpendicular to the undisturbed airflow. Sounds good. Component of the total aerodynamic force perpendicular to the undisturbed airflow, and component of the total aerodynamic force perpendicular to the mean aerodynamic force. Lift is a component of the total aerodynamic force perpendicular to the undisturbed airflow. Let's see what I mean. Lift has two components. Total aerodynamic force, the reaction force, has two components, which is lift and drag. I hope I get better with drawing. Relative airflow. Let's take the easy way. This is lift, this is drag, and this is the total aerodynamic force. So, and this of course here is the center of pressure. So this component here is lift, this is the reaction force, and this is drag. So lift is component of the total aerodynamic force perpendicular to the undisturbed airflow. Consider a subsonic airflow moving steadily through the Venturi tube with no leaks, as represented in the image 1, 2, 3, 4. Identify areas of different speeds. Which of the following sequences correctly identifies the areas in order of increasing speed? We have here number 1, 2, 3, and 4. Number 1 represents the undisturbed airflow. As we go closer to the throat, we have number 2, which we have a slight increase in speed, and number 3, we are in the throat, which the speed is greater. As we go out of the throat, the straight lines are starting to diverge, so the speed goes down. So the areas of low speeds are 1 and 4. Number 2 has higher speed than points 1 and 4, and number 3 has greater speed of all. So the correct answer must be 1, 4, 2, and 3. Let's see. 1, 4, 2, 3. 1, 4, 2, 3. This might be the correct answer. Considering subsonic incompressible airflow through a Venturi, which statement is correct? The static pressure in the throat is the same as in the undisturbed airflow. Doesn't sound right at all. Of course no, because let's draw it somewhere like here. Pressure static 1 and Q1. We see at the point 2, which is in the throat, pressure static goes down because dynamic pressure goes up. So static pressure in the throat is the same. Of course it's not the same, and sentence number 1 is incorrect. The speed of the airflow in the throat is lower than in the undisturbed airflow. Incorrect also, because the speed is higher. Because rhythm lines converge, speed goes up, dynamic pressure goes up. Always remember, in order for this to remain constant, for example, point number 2, dynamic pressure goes up, this has to go down. Both of them are incorrect. Pretty easy one. This is straightforward, incorrect, and incorrect. Which of these statements about weight or mass is incorrect? One more time. Weight equals mass multiplied with the acceleration of gravity. So don't get confused over here. The mass of an object is independent of the acceleration due to gravity. The weight of an object is independent. Of course, it's not independent. In the SI system, the unit of measurement for weight is the kilogram. Of course, not the unit of measurement for weight is Newton. This is the most basic, the most common confusion for almost everybody. This is also incorrect. So the mass of an object is independent of the acceleration due to gravity. This sounds the most correct answer. So it's A. The angle between the airplane's longitudinal axis and the wing root chord line is the flight path angle, angle of attack, angle of incidence, and glide angle. Of course, we are talking about the rigging angle because when we are at the root, it's called rigging angle. But at this point, angle or ring angle is the same with angle of incidence. Let me show you what I'm talking about. And this is also called wash in. Let's draw here our airplane. Mm, I should have done bigger. This is the longitudinal axis line. And this angle at the root is called angle of incidence. The line between the longitudinal axis and the wing root chord line, angle of incidence. The angle of incidence usually varies from root to tip. This is called wing washout, and its purpose is to increase lift at the tip, thus equalizing lift across the wing, to ensure that stall occurs at the root first, maximizing controllability. Of course, this is the correct answer. How we maximize controllability? Because the ailerons are um, are at the wingtips. So if we still have airflow at the wingtips, we still have effective ailerons in case to not have a wing drop. To reduce induced drag caused by wingtip vortices, you reduce lift at the tip, thus equalizing lift across the wing. And also, when stall occurs first at the wing troop, we have something which is called buffeting, because turbulent airflow of the stalled section of the wing hits the tailplane and gives us an indication, a physical indication, that we are on the verge of a stall, of a total stall. So we did pretty fine. I hope you found this video helpful about how we deal with this kind of questions. I hope you understand how important it is to draw the picture, and helps us spot any errors and understand makes us make this easier for us to correct the to pick the correct answer.